So our new topic today is talking about something different. What you mean by something different? Let me explain what you learned before. You learned before, probably we have a beam with hinge and roller. We have concentrated load. We have uniform distributed load. Then we figured out how much reactions. We learned how to solve trusses, for example, supported by these supports under the effect of these forces. Then we learned how to figure out the internal forces in this member and this member and this member and all of these members. But we have something constant until this moment. What you mean? The structure, which is a beam in this case, or truss in this case, is what can I say? Is stable and stationary, in a stationary position. No movement. When I started to solve this problem until this point, until today, until the end of the semester, until the end of the life, the structure is stable, no movement in a stationary position. This load at the same location. This reaction, the same value, only one value. So we are talking about static. Static means no movement. But today we are going to talk about dynamic. Dynamic means the structure, the building, the object, the particle in movement. So this is the only difference, or the biggest difference, between what we learned before this moment and what we will learn starting from this point. The difference between statics and dynamic. No movement, we have movement. If you are projecting a projectile by tank, for example, this projectile will go to a position. So this particle is moving in a certain path to go to a certain position. So we are in the dynamic side. So one of you, I believe, will ask me a good question. Do you think if you have a building like this one, do you think this building will be analyzed under static part or dynamic part? What do you think? Do you think your building is moving? So probably in the morning, if you go to campus, if you return it back to home at the evening, do you think your building or your structure or your apartment at the same location or in a different location? What do you think? If we have a bridge like this one, do you think this bridge, I will analyze this bridge from the point of view of static or dynamic? What do you think? Guys, I have question. This is my question. What is your answer? What do you think? Do you think dynamic is related to civil engineer? Do you think dynamic can be related to structures around us? So how? Do you think your building is moving? Do you think the building is moving? So how can I consider it on the dynamic side? What is your expectation? If your major is construction engineer, you should think about this. Do you think if we have a building, like your building right now, you are in a building right now, do you think this building can be considered on the dynamic side? Do you think we have a movement? Thank you, Mitchell. Thank you, Anthony. The same names respond all the time. Okay, let's start to watch this video and see, do you think the bridge can move? I'm not sure if you watched this video before or you heard about this accident. It happened probably in 1950s. Can you watch the deck of the bridge? Can you watch the effect of the wind on this bridge? These guys considered this bridge on the side of static only. They didn't consider the dynamic effect. So what was the final result? The final is collapse. So sometimes we need to consider the dynamic effect on a building. Like Mitchell said and Anthony, yes, we have effect of wind, we have effect of earthquake. These effects can move or can make the building to move, not from the position, but to vibrate. Vibration means movement. So dynamic or dynamics is very important. I will not cover everything in dynamics, but we will learn a little bit of the basics of this course by learning particle kinematics and projectile motion. So we learned that in civil engineer, an understanding of structural dynamics is very important in the design and retrofit of the structure to withstand severe dynamic loading. Keep in your mind, dynamic loading means effect of wind, effect of earthquake, any dynamic load. Dynamics can be divided into two main parts, kinematic and kinetic. Kinematics is the study of the motion of the particle or the structure regardless how much load do you have, how much force, regardless. We need only to focus on position, velocity, and acceleration. So kinematics is the study of motion without consideration of the mass or forces acting on the system, on the particle, on the structure. Kinematics involves describing particle, their position, velocity, and acceleration. Position means where. Velocity and acceleration, rate change by time. Velocity, rate change of the position. Acceleration, the rate change of velocity. So everything is changing with time. But I didn't consider the effect of force. Then you are talking about kinematics. We have another part or another topic in dynamics called kinetics. Kinetics, we will consider position, velocity, and acceleration, but we have to determine the effect of the force acting on the system, on the structure. We have three basics kinematic equation will be used. We have something called velocity, which is the rate change of position. We have something called acceleration, which is the time rate change of velocity. We have a relationship between velocity, acceleration, and position by this expression. Sometimes your motion in a linear space, which is called rectilinear motion. Sometimes your motion in a circular motion. For any reason, you are walking or moving in a circular motion. We have a good relationship between what is the rectilinear motion and what is the curvilinear motion. And we will cover example number 1 next time. So today, just introduction about our new topic, which is dynamics. So dynamics means we will study the particle or the structure under the effect of dynamic loading. Dynamics can be divided into two main topics, kinematic and kinetic. Kinematic means we will consider the particle's position, velocity, and acceleration regardless how much force affecting on this body. But kinetics will consider the effect of the force acting on the body. Your motion, probably rectilinear motion, which is a linear path, or circular motion, the motion in a circular path. So we have A, V, and S. On the other side, we have omega, alpha, and theta. We will cover all of these terms next time to figure out a relationship between the curvilinear and the rectilinear motion.